For this video, we're going to be talking about section 6.3, which is solving compound inequalities. To start, we have some vocabulary here. A compound inequality is two or more inequalities. In this class, we're just going to focus on two inequalities that are connected by the word and or. A compound inequality containing the word and is only true when both of the inequalities are true. So its graph is where the graphs of the inequalities overlap. This overlapping section that represents the compound inequality is called the intersection. And then we have a compound inequality containing the word or is true if at least one of the inequalities is true. So this one doesn't have to be both, just one or the other. A union is the graph of a compound inequality containing or. The solution is a solution of either inequality, not necessarily both. We will talk about what both of those look like on these graphs right here. So it says consider each set of inequalities. So we have x is less than 7. So if I was to graph that, it would be an open circle at 7, less than, we shade to the left. So then I would shade all the way down and put an arrow at the end of that. Then I have x is greater than 3. So then I would have an open circle at 3, greater than would be to the right, because that's where all the numbers are bigger than 3. And then all of a sudden you see that we actually are going to join them by the word and. So in order for this to be true, the number that whatever x is has to be less than 7 and it has to be greater than 3. So then I would put dots at 3 and 7. Since this is an and statement, we know that it's the intersection of the two graphs. So you'll notice right here, these two graphs overlap in this section right here. So we would shade in between 3 and 7. So basically you have answers such as 4 would satisfy that. 4 is less than 7 and 4 is greater than 3. So then 4 would be a solution. So remember, if it's an and statement, it has to satisfy both of the inequalities. Whereas on the second set of inequalities, we have x is greater than 5. So open circle at 5, greater than would be to the right. Then we have x is less than 0. So open circle at 0, less than would be to the left. And you'll see that when we look at these two together for this bottom one right here with an or statement, this would be a union. X must be greater than 5 or x has to be less than 0. So remember, if it's an or statement, only one of those has to actually be true. These don't overlap at all. So if I just copy down both of those onto one graph, it would look like this. And that would be your graph for this or statement. So -6 would be an example of a solution for that compound inequality. So right here, -6 satisfies, oops, I circled the wrong one, this inequality. And remember, for an or statement, it only has to be true for one or the other. So -6 would be a solution. So would 10, because it's in those shaded regions. Now, the only ones that would not be solutions would be 1, 2, 3, or 4. And actually 0 and 5, since the circle is not filled in, and then any of those decimals in between. So obviously there's a lot of potential answers that would not work, but the graph helps you see very clearly which solutions would work and which ones would not work. So first thing we're going to look at here is 1 and 2, and I'm going to zoom in just a little bit more. It says solve and graph an intersection. So you'll notice that these inequalities are written together. This implies that it's an intersection or an and statement. Whenever they're written together like this, it's always, always, always and. So when we solve these, technically speaking, I'm going to write it down here at the bottom of your screen. You could actually separate this as -8 is less than or equal to x minus 2 and x minus 2, the middle part again, is less than 1. So that's where they're getting the two inequalities from. There are still two. They've just merged them to look kind of like one, but you'll see that we have two inequality symbols there. So it is actually two inequalities put into one statement. Now, we solve these a little bit differently than we're used to because technically there are three sides, if you will, to this inequality. There's the left, there's the middle, and there's the right. Again, you're still trying to get x by itself. So whatever we do to the inside, we have to actually do to the outside, because down here, if I added 2, I would have to add 2 to -8 and to 1. So when you split it up, you have actually a little bit more writing to do. If you would like to split it up, you're more than welcome to. But in this case, all you really have to do is solve from the middle to the outside. So if I add 2 to the middle, I've got to add 2 to the outside two numbers as well. So when I do that, -8 plus 2 is -6, less than or equal to x, less than 1 plus 2 is 3. X is by itself, so then this would be my answer. So we have x must be less than 3. And then if I read this part backwards, it tells me that x must be greater than or equal to -6. So on my graph, I'm going to put -6 and 3. Those are the only two numbers that you need for compound inequalities, just the two numbers that we're talking about. Whereas before you had to put 3 numbers in a row. We're not going to do that for this example. Now, the other thing you have to pay attention to is, first of all, if they're open or closed circles. So the one at -6 needs to be a closed circle. And the one at 3 is going to be an open circle because this one does not have the or equal to part, but this one does. So that's where that comes from. Now, since it's an and statement, you should be able to remember that you do shade in the middle of these two because and is the intersection of the two inequalities. Now, if you wanted to double check yourself, x must be less than 3. So you know that you would have to shade to the left of 3. And then again, I underlined this part right here in orange. If I read this backwards, x must be greater than or equal to -6. I could flip that around if I wanted to. That's where I'm getting the greater than. If x must be greater than or equal to -6, I know that I'd have to shade to the right. You'll notice that both of those orange arrows are pointing at each other. So then we do, in fact, shade in the middle of those two numbers. Looking at number 2, first thing I noticed really quick is this problem is actually not the right problem for what is in our notes. So I'm going to cross that out really quick. Our problem should say 5 is greater than, -3x, and then we would have +2 greater than or equal to -7. Okay, so now that we have the right problem for number 2, we are again doing the exact same thing we just did on number 1. So solving from the middle or the inside out. So starting with that +2 there, we're going to subtract 2 from all 3 sides. So then this would give us 3 is greater than -3x is greater than or equal to -9. Then we're going to have to divide all 3 sides by -3. Now, just like before, when you divide or multiply by a negative, that sign still flips. That rule doesn't ever go away. So then we would now have -1, no longer greater than, it would now be less than x. And then we would have no longer greater than or equal to, it would now be less than or equal to a +3. So then that would be our final answer there. So then if I go to graph this again, we would have -1 on the left, 3 on the right. I do want to make sure I point out really quick, these numbers do need to go in numerical order. So if for some reason they're flipped around in your answer on your number line, you got to make sure they're in the right order. And then after that, -1 is just less than, no or equal to, so then that would be an open circle. 3 has the less than or equal to, so that would be a filled in circle. And then again, I like to always double check that my arrows are in fact pointing in the right direction, or what I mean by that is since it's an and statement, they should be pointing in the middle, meaning an intersection. So then x is less than 3, meaning we would shade to the left of 3. And then again, this inequality right here, I like to rewrite it so that it's x is first, easier to graph that way. So then that's basically saying that x has to be greater than -1. So we would shade to the right of that. And since my arrows are pointing in the middle again, we do shade in the middle here. So that is it for the front. Let's go ahead and go to page 2. Okay, next we have a word problem here. So as always with a word problem, we need to define our variables. So x is going to represent, if I'm reading through this, a cereal manufacturer distributes cases of cereals to the grocery stores. Each case contains 12 boxes of cereal. In order to pass the quality assurance test, the case must weigh between 336.4 ounces and 331.6 ounces, which includes 34 ounces for the weight of the cardboard box. Don't forget, there's also 12 boxes of cereal in the box. And then it says write and solve an inequality that describes the weight of 1 box of cereal. So that's going to be our variable. So weight of 1 box of cereal. Okay, next we need to actually set up our inequality. And you'll notice right here that because it's between these two numbers right here, these two weights, we know that it has to be an and statement. So they're going to be joined together because it says between the two numbers. So we know that it has to be inside of those two numbers. So I actually like to work from the inside and then fill in my outside too. So talking about the cereal itself, each case contains 12 boxes of cereal. So I know that that has to be the one that contains the X. So 12 times the number of boxes would give us the weight, sorry. So 12 times whatever the weight of one box of cereal would be, would give us the weight of the total cereal in there. And then we also have to include this 34 ounces for the weight of the cardboard box. So the weight of that entire box total would be the weight of 12 boxes of cereal and 34 ounces because that's how much the cardboard box itself weighs. Now, it has to be between these two numbers that I've underlined already, so I'll circle them in orange right now, these two numbers right here. So I know that this pink expression right here has to be less than or equal to the bigger number of the two, which would be the 336.4. And then this is where it's tricky. I know that the smaller number has to go over here, but then you have to figure out what inequality sign has to go here. So this pink part must be bigger than this weight over here, this 331.6. So I know that the inequality says less than, but if you read it backwards, and if I write it over here, it would be 12x plus 34 is greater than or equal to 331.6. Remember, this is opening up towards the bigger thing that I want to be the bigger thing. And I know that the weight of the box must be bigger than the smaller weight of the two that they gave us. Hopefully that makes sense. So again, don't look at this. This was just to talk about how that sign makes sense. So now I'm going to go ahead and start solving this. So I'm going to subtract 34 from the inside, and then whatever I do to the inside, I have to do to the outside because you're actually solving two inequalities at once. Don't forget that. So then we would get 297.6 is less than or equal to 12x, which is less than or equal to 302.4. Then we're going to divide everything by 12. So then that would give me 24.8 less than or equal to x, less than or equal to 25.2. But again, since this is a word problem, we have to actually answer it in words. And I'm going to go ahead and take a quick second here to erase this because I'm going to need the room to write it. So I would say that, because again, remember, x is representing the weight of one box of cereal. So one box of cereal weighs, and I can just say between 24.8 ounces and 25.2 ounces. And that would be our answer for that word problem. Next, we have solving and graphing a union, which if you remember from the front in our vocab, this would be an or statement. So we have to make sure that we're careful. Sorry, that looked like a V. I don't know that that got any better, but a union is an or statement. So this should be shading in opposite directions. I like to use that little cheesy way of remembering that. O for or, O for opposite. If it's an or statement, they are shaded in opposite directions here. So you'll notice that there is an actual or in the problem. So when they're joined together, it's implied that it's an and. If it's an or statement, it will tell you it's an or statement. So that's how you'll know the difference between the two. So then when it's an or statement, you just solve them separately from each other. So on this first inequality, I'm going to subtract 8 from both sides. And I would have 4x is less than or equal to, ooh, my pen is glitching on me, sorry, 8. And then I would divide both sides by 4. And I would get x is less than or equal to 2. Then I'm going to solve this other one separately. So minus 7 from both sides. That would give me negative 3x is less than negative 18. And then I would divide both sides by negative 3. But don't forget, whenever you divide by a negative number, we have to flip that inequality sign. So then it becomes x is now greater than positive 6. And then we have to include or in our answer. So then this would be my answer. Now we have to make sure our number line goes in order from left to right. So 2 is going to go on the left, 6 is going to go on the right, and then the 2 is going to get a closed circle because it's less than or equal to. The 6 is going to get an open circle because it's just greater than. X is less than or equal to 2 would be shaded to the left, and then X is greater than 6 would be shaded to the right. So then we can verify that our graphs do in fact go in opposite directions here. So that would be our answer for number 4. Looking at number 5, it was again the wrong problem. So I did fix that really quick. We now have the correct problem on the, I almost said board, on the screen. So then I'm gonna go ahead and subtract 10 from both sides. So when we do that, we have negative 6x is less than or equal to negative 24. Divide both sides by negative 6. Again, we got to flip that inequality sign. So then we would now have x is greater than or equal to a positive 4. Second inequality, we're going to subtract 1 from both sides. So that would give me 5x is less than 15. Divide both sides by 5. And we would get x is less than 3. And then again, don't forget that or in the middle of your answer. We don't combine these together because that would be an and statement. So this is how we would write our final answer. Now, one thing I do want to pay attention to, 4 and 3 are not in the right order right now. So we do need to make sure when we put them on our number line, they do need to go in numerical order. So then at 4, we're going to have a closed circle because it's greater than or equal to. And then at 3, we're going to have an open circle because it's just less than. Now, greater than 4 would shade to the right, less than 3 would shade to the left. Sorry, I got cut off there. So that would in fact support the fact that or shades in opposite directions. So then I will go ahead and actually shade. I just wanted to show the arrows to check one more time. Some people like to do that just to be 100% sure that their graph would actually match what their answer is saying. Now, looking at the last 4 here, they give us the compound inequality. We have to come up with the they give us the graph of a compound inequality. We have to actually write that compound inequality. So looking at number 6, this would be an and statement because it's shaded in the middle. It's the intersection of the two graphs. So I like to write a note to myself and say that it's and. The next thing I like to do is write the two separate inequalities. So for -2, we would have x is greater than -2 because it shades to the right this way. And then we would have x is less than or equal to 4 because it shades to the left. Now, we talked about how and is written together as a joint answer, if you will. It is all combined together. So basically what we're going to try to say is -2 is the lowest number, 4 is the highest number, and x has to be between those two numbers. The shaded region has to be between those two numbers. So then looking at this inequality right here, this says x has to be less than or equal to 4. So then that's actually what I'm going to go ahead and write right here, because x has to be less than or equal to 4. Now, if we look at the -2 and the x, that's in the reverse order of what this is right here. This says x is greater than -2. If you notice, the inequality is opening up towards the x. So when I go to write it over here, my inequality still has to open up towards the x, meaning that sign would actually end up being less than. So -2 has to be less than x. On number 7, this would be an or problem because they are shading in opposite directions. So then for this first inequality, we would have x is less than or equal to 0. Second one, we would have x is greater than or equal to 6. And that actually entire thing ends up being your answer. So there's no fancy way of writing this, no combining it, nothing like that. So just x is less than or equal to 0, or x is greater than or equal to 6. Looking at number 8, again, this would be an and statement. So then writing the two separate inequalities, the first one would be x is, greater than or equal to -7. Second one would be x is less than 8. But again, for an and statement, x is in the middle of those two numbers. -7 would come first, 8 would come last. If we look at the x and the 8, x has to be less than 8. So then I'm going to go ahead and fill that inequality in. Then looking at this one, -7 comes first, and then it's the x, but over here, x came first, and then we have the -7. Again, the inequality is opening up towards the x, so then when I go to write it in my answer, it still needs to open up towards the x. So then in that case, again, it would switch to be a less than sign. Last one here, we have another or statement. So instead of writing the little notes off to the side, because you end up just writing it twice, starting with that first shaded area, we would have x is less than -1, and then we would have our or. We would have x is greater than or equal to 3. And that is it for your notes.